Insuring tanker car safety, a government industrial partnership. Proceedings of the Planning Committee of Federal Railroad Administration in Washington, D.C., January 14, 1979, or 1997. Sorry, January 14, 1997. Insuring tanker car safety. On January 14, 1997, the Insuring Tanker Car Safety Planning Committee met to discuss an outcome of ensuring the tanker car safety public information meeting held in Houston, Texas on February 14, 1996. Committee also discussed minutes in 1996 North American Tanker Car Research Coordination meeting. The RCM held the Association of American Railroad headquarters building in Washington, D.C. on November 19, 1996. In recognition of the participants of the both meetings and contributed insights within the respective operating, maintaining, transportation tanker cars, the Federal Railroad Administration thanks you. The final outcome of these meetings will be realized in years ahead of both of government, industrial research, rulemaking, industrial standards setting activities and mutual desire to achieve improved safety. To this end, of the Planning Committee developed the following priority listing government industries and initiatives to ensure tanker car safety. A summary of each initiative following the main listing. An important note to the initiatives do not represent the hierarchy of safety needs and merely a list of needs of industry and government should review the establishment of long-term research and rulemaking industrial standards setting activities. 1. Non-accident release reduction, NARS. 2. Responding of transportation emergency operation respond. 3. Tanker car damage assessment, mechanical and thermal damage. Tanker car. 4. Tanker car fire protection, thermal molding. 5. Tanker car structural integrity, rail car operating environment, training dynamics, and primarily data collection, quantitative research, risk, and analysis. 4. Reliability assessment in damage tolerance analysis, full structural analysis of car design modifications, design criteria to reduce structural fatigue, welding quality, technology, techniques, stress relief, revealing, inspection of tanker car involved with derailments and overspeeded impacts, life cycle maintenance plans for tanker cars, non-destructive evaluation, pressure relief devices, liquid vapor and two-phase flow, performance-oriented standards for negotiated rule-making, railroad operating procedures, and human factors, and public workshop information meetings and lesson learned. 286,000 gross weight on rail. Safety intermodule portable tanks transported rail. Government and industry initiatives, non-accidental release reduction, NARS, ongoing North American non-accidental release program provided by a cost-effective industrial-sponsored opportunity to reduce number of hazardous materials released, the collection data analysis, communication of the data release, follow-up of the initial shippers, releasing the Association of the American Railroads amended industrial standard of the construction hinge manway, covers of the tank recovery improved, closure design of the identification of manway style, current research and focus by the premature rupture, disc failure, and ergonomic design to loading, unloading valves and fittings. 2. The emergency prepared operational responsive program designed to improve the information available first responding to hazardous material passenger train accident operation. Respond between a funded government industrial project provided by critical information to the first responders in April 1995. Operation Respond became non-profit, not-for-profit organization found for organization providing participating rail or motor carriers as well as user for the system. The Operating Respond Emergency Information System OREIS technical TM connects the police, fire departments directly participating rail motor carriers database verification hazardous material cargo. Their system provides schematic Amtrak's and locomotives instead of seal seat configuration, emergency exit doors, windows, and locations of electrical fuel and sources. For more information, contact Operation Respond at 2222 202 and 906 200770 and OREIS at AROS. Visit Operation Respond Home Depot OREIS.org homepage at www.oreis.org May 1997. Tanker car damage assessment, mechanical thermal damage, FRA Review and evaluation of the present tanker car assessment and procedures currently used in railroad emergency response. In addition to the review of current procedures, this risk of the activity will validate additional presently used parameters such as fire damage to a tank shell. Tanker car fire protection and thermal molding. As early as 1984, the government industry have been developing analytical procedure calculating the effects of fire on the railroad tanker car. The procedures developed that the consequently using the conduction of the thermal insulation on the tanker car differs from the flow capacity of pressure relief and devices could be determined. Analysis is used to predict the time the failure amount of the product remaining in the tank at the time of failure for both upright and overturned cars. The model is developed based on the full-scale research on loaded tanker cars containing the propane of 1975 research is validated in a model of commodities such as chlorine, anhydrous ammonia, and other gases. In addition, there is a need to improve the friendliness of the program of all users. Tanker car structural integrity, railcar operating environment. A railcar is designed and built, maintained for expected operation environment. Significant factors for safety currently cushioning of railcar damage is known as but qualified quantity and deviations in the actual operational environment. Expected environment. The accidental loads to make more closure understanding of actual risk must be considered operational maintenance of railcars as well as to minimize risk is better to understand the railway car operating environment must be obtained. The environmental, including the war variations due during the train makeup, track and truck conditions, temperature, as well as the train handling must be studied and documented. Track training dynamics or track vehicle dynamics refer to interaction railroad vehicles, locomotives, and cars, while track is affected operating practices, terrain, environmental conditions studied as a track. Train dynamics have been particularly useful determining the causes of combination of derailments wherein several factors contributed to derailment, but each factor is considered immediately would not normally result in derailment. Train dynamics has fully been established in design safety standards, but both equipment and tracks has been determined per operating practices, e.g. handling. Current research is empty loading distribution may lead to better understanding of forces experienced in actual train movement and optional location of the place cars further and is needed to understand effectual train dynamics on car structures such as accelerated fatigue due to the vibration. Empirical data collection and quantitative risk analysis. Ongoing empirical data collection efforts of the Federal Railroad Administration Research Special Programs Administration, RSBA, Association of American Railroads, AAR, Railroad Progress Institution, Association of American Railroads, the RPI, and the AAR, Cooperative Railroad Tanking Car Safety Research Project instrument in helping identify the prioritized railroad tank safety advance of over than 20 years. Use the appropriate empirical complement, theoretical modeling, engineering approachment to estimating the system performance, reflecting the performance of the similar systems in actual operating accident environmental current data collection efforts will continue to have the value of additional opportunities to take advantage of actual experience should be carefully considered. Qualitative risk analysis. The QRA refers to the family of techniques used in empirical load or empirical data to risk the infrequency or likelihood of various undesired events and associated with the transportation of hazardous materials by rail. Hazardous materials rail scenarios occurred very infrequently due to high level of safety of normal operations. Indeed, the consequences that are possible have been occurred in simple empirical and alone cannot estimate the likelihood. However, the potential consequences should be might to be very large, and even if rare, such possibilities disregarding the management risk and QRA techniques develop the quantitative information about such low frequency events as well as more routine types of incidents, thereby risk management to make must cost effectively safety investment. And reliability assessment. The reliability of the tanker car is probability while operating, understanding environmental conditions, tracking, performing, intending to function, and actually specified interval. The assumption is made possibility of the failure, welded joint and shut. Material is strength, ductile, well thickness, and deteriorate within time. Associating tanker car reliability mode of failures, defined categories, fatigue, corrosion, procedural constraints such as preventive maintenance and repairs are established. To damage tolerance analysis, the dynamic nature of the rail environment, including the variable cyclical loading, normal accidental impacts, varying exposure to corrosive environs, making it difficult to perform a realistic evaluation expected in life of a railroad tanker car. However, DTA analysts deterministically abstrain or consider the important loading environmental variables which drive tanker car reliability. Evaluations performed using the DTA ideally suited for the allowable tanker car operations. A tailored inspection maintenance program for the individual fleets. Validation testing of the one owners of the DTA is currently underway, but will be utilized to refine the DTA methodology to apply to the tank designs. Full structural analysis of car design modifications. Once railroad cars have undergone modifications, the rail tank and sill load passable sill and tank may have been altered, though original tanker car design change and structural responsive significantly may be changed in inspection, maintenance, and modified tanker car detailed analysis. Tanker car design property modification design is necessary to fully understand the new requirements of maintenance used as modified tanker car. DTA analysis currently evaluating the structural variations will result in different design criteria to reduce the structural fatigue. Guide engineering design optimize desirable design features with tanker design and past empirical data. The optional will reduce structural fatigue. However, new engineering tools become available to the railroad industry, such as the DTA new available non-destructive stress monitoring methods, weld quality technology techniques, stress relieving, reliability of welded joints dependent on the chemistry of the weld, combination of the filler-based and flux actuating slag condition of the welded materials, welded fatigue, including the qualifications of the welder health, heat input, interpass, temperature, pass weld, heated treatment, stress, revealing depth of penetration, fusion, mix of the variables determine the soundness of the finished weld to improve the inherent reliability, safety of the welded joint. Government industrial must be studied in an interrelationship between the variables. Optimized mix of the produces the weld and is free to effects of the reduces the intended service life of the welded joint. Inspection of the tanker cars involved in derailment and overspeed impacts. Rule 95 of the Association of the American Railroads interchange rules applies to handling carrier. The acknowledged damage, loss, and any of the resulting unfair uses. This rule is others is not specific respect inspecting the sub-sill of the tanker cars involved in tanker derailment and over speed impact. When a tanker car experiences derailment over the speed impact, mandated inspection of the sill structure, tanker achievements will consider ensure the damage is detected before such damage can grow to critical size. Sub-sills and shop down due to an accident derailment and are currently required to be inspected. However, there is no provision at the present to inspect the following at an overspeed impact. Life cycle maintenance plans of tanker car. Single car is an obligation to ensure the quantity continued qualifications of maintenance of the tanker car. It logically follows the owner and what must be developed as a set of procedures and cover and design maintenance repair. Recognize the effects and fatigue and corrosion of the tank structure. The plan should set specifically qualifications, material maintenance intervals to achieve the maximum service reliability to ensure the timely inspection of maintenance, and the detail should be identified there in areas to inspect. The inspection of test method and the exception of the criteria inspection of the test frequency of the DTA methodology will provide technical base of such plans. Non-structural evaluation. The regulation were recently amended to replace the periodical hydraulic test within non-structural evaluation methods of adequate inspection of flaws and important compatibility methods, respective profitable detection and forecasting of existing transportation technology centers. Non-destructive evaluation, the NDE project when extend to the accommodated additional applicable test procedures. New NDE non-destructive evaluation methods will continue to be monitored and applicably. Pressure relief devices, liquid vapor and two-phase flow. Current federal and industrial safety codes to use the pressure relief and for adequate flow capacity under the vapor flowing conditions. Often the operation of the pressure relief devices, transportation continuing involved in accident lies below the plane of the liquid level of the cargo, and orientation under the fire condition of the saturated liquids, the two-phase flow of the pressure relief device causing liquid flash. A flash with liquid will cause decrease the required flow capacity of the pressure relief device. Research is needed to study the two phases of the flow of the pressure relief device and its effect on the pressure vessel. In addition to the further research is needed to study the vapor pressure of certain committees of fire conditions in the material polymerize or decompose the evaluated temperatures, and for fire conditions higher vapor pressures of cargo may be required of the pressure relief devices PRD and they have greater flow capacity under the prescribed under the current rules, and research and the contractor determine the proper flow capacity required as these materials. Performance-oriented standards general preferred to engineering and design standards because of allowing the regulated to achieve the regularity objective in the most cost-effective way, and then general performance standards should be there when performance can be measured reasonably imputed, and standards should be so written that there is more than one way to meet it. Example of performance standards in coupler and vertical restraint systems, shelf couplers, thermal protection systems, fire protection systems, head puncture resistant systems, head protection. Examples of design-specific standards including tanker shell thickness, pressure relief device flows, capacity, installation requirements. 7. Negotiated rulemaking. To achieve requirements in railroad transportation safety requirements, both coordination and cooperation is made by both government, industry, and establishing federal safety rules as a means of authorizing federal agencies to collect knowledge of industrial. Congress enacted the Negotiated Rulemaking Act of 1990, establishing statutory framework for the federal agency to formulate rules, bringing together representative of the agency with affected interests, and process that provides both government and industrial learning to the issue as a hand, providing the rule is likely to receive judicial review. Railroad operating practices, human factors. In 1985, the human factors accidents have been accounted for approximately one-third of all railroad accidents. Reduction of the human factors accidents requires examination of current railroad operation practices in anticipation of the future safety of the current practices given in industry trends. The program targets human factors in yard, terminal, and mainline train operations. Work proposed FRA over the next 5 years, including the evaluation injuries in yard terminals, maintenance of the way operations, as well as ergonomical issues associated with them. Work will be done to attest the training for the employees handling hazardous. Other projects will focus on gaining enhanced and understanding fatigue and locomotive engineering displacement other than operating personnel, identifying the mitigation and strategies such as napping and vigilancy, monitoring studies will be done, incorporated new information and displays technology, railroad environment, and formation of the effective training along the operational personnel effective of the boredom and active on operative performance will be investigated. 9. Public workshop information meetings, lessons learned, a parting of labor management, tanker car operators, owner leasers or leases on car manufacturer repair facility solicitations of safety issues are found on unified policy decisions, involvement of all parties to process ensure the most appropriate business decision as are made earlier, and key safety are not overlooked. The essence of government industrial partnership will further lead to effective and efficient government since the least government rescues is arbitration and labor management disagreement over the safety concerns. Public workshop means public workshops and meetings that provide the information and lesson learned and practical experiences excellent vehicles for all materials to understand the applicability of rule and questions such as meetings and providing interactive process of clarifying key elements of final rule for gaining knowledge of government safety concerns and industrial limitations for prior proposed. Where a final rule may be seem logical, planned on paper, or agreed on, but to all parties, but the true test of the rule is implementation. For example, does the current rule recognize the limitations of the car repair facilities to inspect the required areas of operation? Will the industrial activity promote the sensitive reliability testing equipment on an acceptable level? Can a non-destructive exemption personnel interpret accept non-applicable findings, minimum maximum detectable flaws, sizes, the minimum qualifications, non-destructive testing personnel? The answer to the question relies not only on the interaction between government and industry, but more importantly, the effectiveness of the individual car owner to accept responsibility establishing qualification maintenance to ensure the reliability of any service tank meeting failures or rates at acceptable level. For the reason of the promotion meetings of the focus on lessons learned in the qualification maintenance of the tanker car within the further the knowledge based in the entire industry. 286,000 gross weight on rail. The rail industry moving rapidly in construction operation car will gross loads up to 286,000 pounds. Tanker cars of builders, owners, and presently submitting applications to the Department of Transportation for the use of heavy gross weighted cars. Fatigue to analyze and perform that these cars are used as scales of Festa 1 and Festa 2, loading and spectroid data, and to account the increase in longitude vertical coupler load. However, before considerization requirement, the department must study the appropriate scaling factors and understanding the changes in the training forces changes the gross weight developed in review of the FRA research involving train operations engineers, simulators, tows, atoms, computer models, translating the studies to heavier weight train cars and issuing the buckling of large tanker cars will also be investigated. 11. Safety intermodule portable tanker cars transported railroad. The Transportation Research Board of Insuring Tanker Cars Special Report 243. The board voiced concern in respect to transportation intermodule portable tanks by rail becomes the intermodule portable tanks relative to the United States experience ensuring the safety rail environment is limited. The board recommended by the DOT conduct through a review of the tanker car safety because of the design and maintenance of tanker cars subject to international regulations. There is international trade partners, including the government agency, safety aspects, promoting development, international database of tanker container failures.